then the ice. That layer structure is very similar to what we see on Europa. So underneath the ocean, there is this big rocky mantle. And actually, we think that there may be hydrothermal vents on the floor of the ocean, just like there are on Earth, and that's where life may exist.
Wow. Okay. Yeah. We can probably squeeze in one more. This one's also on Instagram. Do rockets travel at the same speed in outer space?
It's a great question. So when they're traveling through the atmosphere, the air slows them down. They have resistance from the air. But once you get into space, you can go a little bit faster for the same amount of, boost. Additionally, once we get into space, our spacecraft is going to go about somewhere between a huge variety of speeds that we end up at getting out to Jupiter.
Wow. Thank you for that. Again, thank you for your questions. #AskNASA. Okay, we're coming up on another fueling milestone. Let's check back in with Daryl and Mick.
All right, thank you very much. And fueling going well right now. We're watching some telemetry on our screens right now. We've got RP1 on the first stage, about 75% complete, about 70% complete on LOX also on the first stage, but we're almost done loading the RP1 on the second stage.
Yeah, stage 2 RP1 load complete, should be finishing up here shortly and getting ready for LOX load on stage 2. So things
stage 2
continuing
RP1 load is complete.
There we hear the call out for a complete of RP1 on stage 2, but things are moving forward with propellant loading, getting ready for launch.
And now you see that LOX being vented out of the booster, which is condensing the warm Florida air here, which we have a beautiful day today. So it's really the only cloud that's in sight.
Yeah, it's a beautiful sight that you see there on your picture of on the screen of Falcon Heavy, looking really good as propellant load continues.
As we look up there, you can see towards the top where Europa Clipper, the spacecraft and the star of the show, is sitting inside of its fairing. You can see the NASA logo at the top. And on this view, you can see the Europa Clipper logo, which is just below it, which is a pretty neat design that they made. I want to give you a little closer look at it. It was designed by the JPL team. Cynthia Phillips says she designed it to be something beautiful, something abstract and representational. We actually have a shot of that graphic, if we can pull that up. And there it is. It's a nice logo. The blue-white color scheme represents water ice, the elements on Europa being studied by the spacecraft. The shape looks like a snowflake or an ice crystal. And those two V-shaped portions represent the flybys, each pass of Clipper as it swoops in and then retreats. And then the dot in the center can be Europa, and the star shape can be the spacecraft. They put a lot of thought and design into this logo.
Yeah, it's a beautiful logo. Everybody is on board. It's just incredible to me how much the team, the community, and everybody's just excited about this mission and science, as Jenny was saying. And I know she's excited for this also, she and the JPL team, but beautiful logo.
Yep, looks good on a T-shirt and on the side of the rocket.
Stage 2 LOX load has started.
And there goes stage 2 LOX load. So the final tank that needed to be filled has begun as we continue to make great progress tanking this vehicle. We'll send it back to Megan and Jenny.
Great to hear that tanking's going well. All right, NASA's ambitious journey to Europa has inspired U.S. Poet Laureate Ada Limon to write In Praise of Mystery, a poem for Europa. It is such a powerful piece. Please check it out.
In Praise of Mystery, a poem for Europa. Arching under the night sky, inky with black expansiveness, we point to the planets we know. We pin quick wishes on stars. From Earth, we read the sky as if it is an unerring book of the universe, expert and evident. Still, there are mysteries below. There are mysteries below our sky. The whale song, the songbird singing its call in the bough of a wind-shaken tree. We are creatures of constant awe, curious at beauty, at leaf and blossom, at grief and pleasure, sun and shadow. And it is not darkness that unites us, not the cold distance of space, but the offering of water. Each drop of rain, each rivulet, each pulse, each vein. Oh, second moon, we too are made of water, of vast and beckoning seas. We too are made of wonders, of great and ordinary loves, of small invisible worlds, of a need to call out through the dark.
We had a little bit of technical difficulties there. The package paused a little bit, but I still think that you could really feel how powerful that piece is. And now we're so lucky to have Ada Lamone here with us. Thank you so much for being here. That was so moving. I was getting goosebumps.
Oh, thank you so much. It's such an honor to be here. Such a thrill.
I want to ask you, what made you want to write about Europa, and how did you find, I mean, truly the perfect words for that piece?
Oh, thank you. I think for me it was so incredible to be invited to write this poem. And when I was struggling with this incredible prompt and this incredible ask, I realized that it's not just a poem that's going to Europa, not just a poem that's on the Europa Clipper, but a poem that's for us. It's a poem for everyone here on Earth. And that was really important to me as I tried to choose the right imagery and the right language.
Mm-hmm. Not a tough ask at all.
No, not at all.
And not only that, but we're taking your poem with us. So we have here a replica of the vault plate. This is the plate that's going, that is part of our vault on the spacecraft that's protecting all the sensitive electronics from all that radiation. And it's written in your own handwriting.
Yeah.
How does it feel knowing that a piece of you is going to Europa?
You know, one of the things that I keep focusing on is that it really is a poem for all of us. Mm-hmm. But when they asked me to do it in my own handwriting, my grandmother, who passed away a year ago, she was the one who taught me to really make my handwriting as perfect as could be. And every time I look at this piece, I feel like my grandmother is part of this project too.
I heard you had to rewrite it a few times to get it just right.
You think? Yes, many times.
The handwriting is as beautiful as the poem itself, I assure you.
Thank you.
And what do you hope people take away from this?
You know, I really hope that as we embark on this incredible voyage together, that we are reminded of the wonders all around us, that it's not just in these huge moments of exploration that wonders exist, but that they are everywhere around us all the time. Mm-hmm. And we can't be lonely if we are all connected to this universe.
Mm-hmm. Well put. Thank you so much. And I mean, one other note that I want to point out is, you know, Jenny has always talked about this, that mix between science and art. I mean, really, there is a connection there that we should be talking about.
Yeah, I think that it's so important. And in fact, we do ourselves a disservice when we separate arts and science because we're connected by curiosity and wonder.
Perfect. You are so well spoken. I see why you're the U.S. Poet Laureate. Ada, thank you so much for being here. We really appreciate it. And thank you for the beautiful piece of poetry you gave us for this mission.
Thank you. Thank you. It's been the honor of my life.
Thank you. Thank you so much. All right. So if you are inspired, really, as Ada was, to write about our universe and you want to write your own poetry, the QR code on your screen now is going to take you to a space poetry writing activity brought to you by NASA JPL. All right, another check of the clock. We are now 11 minutes, 51 seconds and counting from liftoff. Jenny, let's squeeze in a few more NASA social questions. What do you think?
Absolutely. I'm ready for them.
Okay, let's pull the first one up on the screen right now. This one is, how can we convert images to evidence of valid life and organisms? If it's proven, what are the next steps?
Absolutely. So, you know, Europa Clipper is not a life detection mission, so we're not trying to prove that there is life there now. But what we are trying to do is characterize if this could be a habitable environment. And so, but even so, the images that we're going to get, we learn so much from images. Even just, looking at a photograph of the surface tells us a lot about the geology, why the surface looks the way it does. Those shadows, why do they look like that? That can tell us what's going on underneath that causes the surface to look that way. And so that tells us about the ocean. So there's a lot that we can infer from even just looking at images of the surface.
Yeah. I mean, considering that you're talking about this, let's actually pull up a picture now. So, we said earlier that prior missions sparked our interest in Europa. Well, this is a 2022 pic from the Juno spacecraft taken from less than 310 miles above the moon's surface. And you see all those fractures. That's what Jenny was talking about, the fractures, the ridges, the bands that crisscross the moon's surface. I mean, from this image, that's how you guys discovered that maybe there is something happening underneath there.
Absolutely. It's part of how we know that there is water underneath the ice. When you think about our moon is covered in craters, right? It's just pockmarked, and so many bodies in the solar system are that way as well. But Europa's surface is really different. There are some craters, but not very many, and that tells us that it is a kind of a young surface, at least geologically speaking, and that begs the question of why. So,
Right.
that was one of the kind of avenues of scientific questioning that we had that led us to believe that there is water underneath the ice.
Right. So what else do we know about Europa? Well, it is Jupiter's fourth largest moon and only slightly larger than our moon. It's really, really cold at Europa. Surface temperatures range from about minus 210 to minus 370 degrees Fahrenheit. Scientists estimate its ice shell is 10 to 15 miles thick. And because of all that ice, Europa is six times brighter than our moon. The spacecraft now on internal power. There is strong evidence of our ocean, of an ocean beneath that icy crust that could hold over twice the volume of Earth's oceans. And then Europa orbits Jupiter every 3.5 Earth days, with the same side always facing the planet. That is super fast.
That is 3.5. Think about that for a second. 3.5 days to orbit Jupiter. That's so fast.
Yeah. All right, and let's take a look at the launch countdown again. We are now 9 minutes and counting until Europa Clipper launches, and no issues to speak of right now. The weather conditions are fantastic. I mean, take a look at your screen right there. Jenny, how are you feeling?
I am just absolutely buzzing. I'm feeling very enthusiastic, a little bit nostalgic, just so exciting. I'm really excited to get Clipper up into space where it belongs.
Yeah, I know this is super thrilling for you and the Europa Clipper team, but this is also a huge moment for astrobiologists and really the scientific community at large.
Absolutely. So astrobiology is kind of the study of how, life is distributed
Center
around the
core
universe.
RP1 load is complete.
And so one of the things that, is really exciting about Europa is that it's a place in our own solar system that could be habitable. And so this, going to Europa to study it means a lot for the astrobiology community and, of course, for humanity at large.
Well, Jenny, here we go with the final moments of the launch countdown. Let's head over to Daryl and Mick.
All right, thank you very much, ladies. And here at Hangar AE, we are continuing to monitor the launch countdown. And so far, we're at T-minus 8 minutes and counting. We're listening to the launch teams. They are monitoring some temperature data coming from the second stage LOX line that goes to the engine there. They're gathering data, so we're going to keep an ear and an eye on that. So far, everything else looks to be tracking okay.
Yeah, everything's proceeding forward with propellant load, and we did hear that stage one RP1 is complete on the three
PY
boosters.
RP1 load is complete.
So things are continuing to move forward there, and propellant loading will be finishing up here shortly as the team gets the vehicle ready.
The team at JPL in California also on console for their spacecraft, just shifted their spacecraft to internal power.
Yeah, they started transitioning everything to internal power. We'll get full confirmation of that in about 2 minutes, but things are good to go. And things are looking good on the preparations for the spacecraft as we move forward.
Engine chill has started.
There we hear the call for booster engine chill started on the 27 Merlin engines, getting ready for a liftoff at 12:06 p.m. today.
T-minus 6 minutes and 45 seconds and counting for liftoff of SpaceX's Falcon Heavy rocket with NASA's Europa Clipper spacecraft. At the very top, It is a beautiful day here in Florida for launching a rocket.
NYRP1 load is complete.
As we wrap up loading the RP1 in the first stage boosters, we've just seen all three go completely filled. Now we await for all three of the LOX tanks inside the first stage booster to get to their full point. You can tell they're most of the way there. As you look on your screen there, you see the cold, the icy cold rocket condensing that Florida air.
Yeah, the team's continuing to load second stage also with LOX, and we're getting very close. We can see on the telemetry here that the LOX load of the three boosters is getting near completion. The team is continuing to follow the procedures and look at the vehicle, make sure that we are good to go for a launch at 12:06. But things are progressing per the procedure, Daryl, and all is looking good for a great launch with this beautiful weather that we have at Launch Complex 39.
Coming up next, we are going to start configuring the tower, the strong back from the rocket. That happens in a little less than a minute.
We just heard from the SMD and NLM that the spacecraft is verified on internal power, and things are looking good for the Europa Clipper spacecraft.
We're also listening to the launch teams as they discuss the data coming in that they're looking at for the rocket.
The teams continue to follow the procedure, as I said, and work the loading of propellant, finishing up the topping of the three boosters and the second stage. As we mentioned earlier, the three boosters are expendable fully. They will not be coming back for landing today. SpaceX is getting the team ready to launch this vehicle today.
And you just heard the call out that the strong back is retracting. That strong back appears to have retracted. So we're getting some discussion on the nets regarding the second stage.
NY LOX load is complete.
As we just got completion of LOX load for the Y booster. We're looking for now the center core and the plus Y.
NLM, it's the LD on the count.net with a final status check.
Yes, LD, this is NLM on countdown 1, NASA spacecraft, and the NASA team is go for launch pending resolution of the anomaly.
Copy, go pending outbrief of the issue being discussed on the anomaly net.
Affirmative.
Okay, Tim, so they've mentioned that they're working an anomaly. Tell me a little bit about it.
Yeah, so as we mentioned, they're monitoring some temperatures on the second stage, and things are the teams continue to look at that as they continue filling second stage with liquid oxygen. They're continuing to look at that and monitor
Center
that
core,
as far as they can into the count. So things are continuing to progress forward with LOX load. Center core is just finished up, so all three boosters are filled with LOX and RP1. Second stage has RP1 on, and we're getting near completion of stage 2 LOX load as the team continues to look at that temperature in the second stage. But we did hear NASA launch manager Tim Dunn tell Charlie Meyer, SpaceX launch director, that they are go for launch pending the resolution of this temperature issue. So the team has continued to work that. And the team will continue to progress forward in their procedure.
And so these discussions are happening very quickly as we are counting down now inside the final 2 minutes until liftoff.
Absolutely, and we just heard that stage 2 LOX load was complete, and the team is working that. And as you said, this is what they do in the last few moments before launch. They're working their procedures, following their processes, and having these discussions. but we are still progressing forward towards a T0 of 1206, and things are progressing forward for the launch this morning.
Ground gas closeouts.
We are now 90 seconds until liftoff. Weather is 95% go. These boosters on the outside, they have flown before the Psyche mission a little more than a year ago. They are back on the pad along with a brand new center core booster and a spacecraft bound for the Jupiter moon Europa.
Yeah, Daryl, I can confirm, listening to the
Heavy is in
teams, that
startup.
everybody is go for launch. They have resolved the temperature issue they were looking at on second stage. Everybody's given the go for that, and Falcon is in startup, so the flight computer has taken over. We're getting
SpaceX launch director is go for launch.
And there we hear Charlie Meyer say that SpaceX is ready for launch, and Europa Clipper getting ready to lift off.
There's a great update as now it vents out the locks inside the line of the transporter erector. We are inside of 30 seconds.
30 seconds and counting.
Minus 15 seconds and counting.
And here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Liftoff of Falcon Heavy with Europa Clipper, unveiling the mysteries of an enormous ocean lurking beneath the icy crust of Jupiter's moon, Europa.
Engine chamber pressures are nominal.
See that the chamber pressures are nominal here. All 27 Merlin engines look great.
Rocket beginning to roll. Putting down 5.1 million pounds of thrust. Coming up, they're going to back off those engines just a bit.
So we're getting ready to head into max
Power and telemetry nominal.
Here, the power telemetry on the vehicle are good there. Everything's looking really
Falcon
well.
Heavy is supersonic.
They have reduced power in the center core to get through max Q, maximum dynamic pressure on the launch vehicle. As we approach that, the two side boosters at full throttle.
A beautiful shot there is our camera team.
Max Q.
Locking into the rocket on clear blue sky. The view from the booster camp back down on Earth.
And there we heard the call for max Q. The vehicle is passing through maximum dynamic pressure. Next thing up in about 2 minutes will be booster engine cutoff, where we see the two side booster engines, all 18, shut down and get ready for booster separation. But the vehicle is performing very well. Looking at all the telemetry that we have, power and trajectory are nominal.
We've been flying for just under 2 minutes so far. Everything looking good. These side boosters, once they do their job, they will be expended. If you're familiar with the Falcon Heavy, you know that they bring the boosters back on certain launches, but not on this one, because all of the performance is needed to push Europa Clipper into its proper orbit.
Things continue to look good as the vehicle heads down its ascent phase here. All telemetry is looking very nominal for this flight this morning. Falcon Heavy is performing very well.
Now we're just about 30 seconds away from separating those side boosters. Their engines will cut off first, then they will separate.
MVAC is chilling.
Starting to chill down that MVAC-D engine in the second stage.
And that's where we need to get the engine chilled to the proper temperatures before flowing liquid oxygen and RP1 into it. So they're conditioning the engine to make sure things are ready for when it's ready to start up.
Stand by for booster separation.
Booster engine cutoff. Side booster separation confirmed.
There they go.
Those two boosters previously flown on Psyche. This will be their 6th flight. We thank you for their service this morning. They did a great job of getting Falcon Heavy and Europa Clipper on its way as the center core takes over and continues mission down this ascent. Things are looking really good in the telemetry. Power and trajectory look nominal, and chamber pressures on the 9 center core engines look really good.
And just a little more, 20 seconds from now, we'll get the cutoff of the main engine on the center core booster that remains. 4 seconds after that, we will separate. Flying out over the Atlantic Ocean. There's a look from inside.
There we see stage 1
Stage separation confirmed.
And stage separation from the center core. Getting ready for MVAC startup, SES-1.
We're getting some applause here in the Mission Directors Center, and there you see the MVAC-D engine lighting up.
Next thing up in about 10 seconds will be fairing separation.
NYPY FTS has saved.
And the fairing has protected Europa Clipper on its ascent up into space, but once we get into space, we don't need that fairing anymore.
Fairing
so there they go.
separation confirmed.
Fairing has separated, and those will be recovered, Daryl, by SpaceX's own recovery ship, Go Cosmos.
And there you see them falling away into space. That is the only part of this rocket that will be recovered.
The glow of the MVAC-D engine as it performs its first burn here. This is about a 3-minute and 47-second burn. Things are looking great. Matter of fact, this is one of the shortest first burns that has been done on a Falcon Heavy by SpaceX, but it is required to get us into that parking orbit for that long coast that we have to get ready for the interplanetary trajectory that we're going to need to get Europa Clipper on its way that we heard Jenny talk about to get those Earth assists in today's mission.
Usually those burns are the other way around, with a longer first burn and a shorter second burn, but in this case, it is reversed as we look at some crystal clear views of the MVAC-D engine, the stage 2 that's carrying Europa Clipper. Orbital light is shining both on the spacecraft, the second stage, and on planet Earth.
Center core FTS has saved.
There we've heard that the flight termination system on the center core has been saved as it heads back to splash down. Things are looking good. I can tell you, Daryl, we had a beautiful weather day for launch. And as we're looking at MVAC flying in space with Europa Clipper, it is such a gorgeous view with Earth behind it. And so we could not have had a better day for a mission launch today.
No doubt about it, Mick. It was simply gorgeous. We had a hurricane a week ago, but after that pushed out, it brought us in its wake near perfect weather for launch. And now we're into space, dealing with the harsh conditions up there.
Stage 2 FTS is saved.
Stage 2 has made its way into space far enough away for us to be able to safe the flight termination system from a safety perspective. We're about a minute away from second stage engine cutoff as we'll see the MVAC-D shut down and get ready for a long coast, getting Europa Clipper into that parking orbit and on its way for the next firing that we will have, the second stage, number 2, to get it into that interplanetary transfer orbit that we need to get Europa Clipper started. So things looking very well this morning. We're about 30 seconds from that stage engine cutoff, which we refer to as SECO 1.
That's right. We'll get into that. Get into that coast phase. These views brought to you, of course, by ground stations across the track that are pulling in a high-resolution data from the cameras. Burn looking good, just a few seconds away from cutting off from that first burn. And there it goes. The first burn is complete.
Yep, things look really well on the stage burn result. Apogee, perigee, and everything for the mission looks really good. Engine performance, very well performance by the second stage for this first burn. And things continue to look good as we head into this long coast for this parking orbit.
It's a long coast, and we'll hit that second burn. roughly 3 minutes and 21 seconds long. This one was roughly 3 minutes and 9 seconds. And Mick, you saw the data from it, and it all looked pretty good. And there you go,
Yep,
confirmation.
We're hearing confirmation that we have nominal orbital insertion. As we were looking at the telemetry here, Daryl, that things looked very good. Stage 1 and stage 2 performed very well on that ascent flight. And we'll continue to follow stage 2 to get ready for that second burn. And then, of course, what we're really looking forward to, Europa Clipper separation.
It's going to be a beautiful moment. If the pictures are as clear as we've seen so far, we will see it in all of its glorious detail. All right. We will continue monitoring the coast phase of the second stage with Europa Clipper, and we will bring that to you. Of course, any updates that we have, we'll check back in with you in a little bit, but for now, let's send it back to the host desk with Megan and Jenny.
Oh, wow. I mean, if you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw a SpaceX Falcon Heavy rocket soar off the launch pad with the Europa Clipper spacecraft. I thought, I'm surprised you're here and composed, to tell you the truth.
Yeah, you did a good job of keeping me upright watching the launch.
Yeah, how are you feeling? How was it to see that and feel that too? I mean, that was honestly one of the loudest and most powerful rocket launches that I've personally felt here on the Cape.
It was very emotional in a good way, right? Just kind of overwhelming with just the awe of it, and that it's finally going up into space, and just I feel almost at a loss for words.
Yeah, I know. She was like, I am sobbing. I am sobbing. I am sobbing. I mean, but everybody can understand that, right? I mean, and this is one of my favorite parts of being part of the broadcast, because I do get to watch it with the co-host, and really, this is so much of your life that you're seeing culminate in a rocket launch.
It is. It's a huge. Again, it's almost indescribable. Just the amount of time and effort and all the people involved that got us to here, and to witness that moment is just unlike anything I can describe.
And can you believe it? We are still very much at the beginning of this spacecraft's journey. It is headed for Jupiter's icy moon Europa, which scientists believe could be the best chance of finding the ingredients for life outside our planet. It will take the spacecraft 5.5 years to travel the nearly 2 billion miles to Europa. This is a mission developed by NASA's Jet Propulsion Laboratory in California and Johns Hopkins University's Applied Physics Laboratory in Maryland. Now, Jenny, why does the team think that Europa is the best chance of finding those ingredients for life as we know it?
Yeah, on this planet, everywhere we find water, we find life. And so, that we think that there's this massive ocean of water underneath the ice on Europa is just, how could you resist? So we think that Europa has that water. That's one of the key ingredients for life, along with the chemistry and the energy and the time. It's been kind of simmering away for a long time.
Sure.
It's a great place to go explore.
And how exciting would it be, right, if we could verify that there are the makings of life as we know it on Europa? So let's dig into the science that is going to make this possible.
We have several ocean worlds in our solar system. And by exploring Europa, we're getting a taste of what these ocean worlds are like. Europa probably has beneath its icy surface a global ocean of water.
We think there are thermal vents in this vast subsurface ocean. There may be primitive organisms there, similar to the original primitive organisms on Earth from which we all evolved.
I just love Europa's surface. I think it's one of the most complex surfaces in our solar system. Typically, when you look at another planetary surface, it's covered with craters, just like our moon.
There are shockingly few impact craters. That means something's going on to erase the craters, just like happens here on Earth, and on Earth we call that geology. One of the key questions right now that we have about Europa is whether or not there's plume activity.
Plumes are one way that you can definitely get ocean material to the surface. We really need a spacecraft in the system that's watching Europa to see when those plumes are happening, if they're happening. Europa Clipper is orbiting Jupiter, and it's performing 49 flybys of Europa.
Each time we make a flyby, we turn on all of the instruments at once.
Most of us know about cameras because that's what our eyes see, but there is a whole slew of other instruments on board Europa Clipper that expands our vision.
We have 4 different instruments that we're really using to take images of Europa's surface. We have the visible wavelength, the near infrared, the far infrared, and the UV, the ultraviolet.
We're hoping to see evidence of change, new cracks, new surface colors that indicate different materials maybe have moved around or come up from the subsurface.
We have an instrument that can sniff the very thin atmosphere, the gases, and determine the composition with extreme precision. And we have another instrument that can tell us the composition of dust particles.
We have a magnetometer and a plasma instrument that are going to be studying that magnetosphere environment that Europa is sitting in and Jupiter's magnetosphere environment.
The magnetic field of Europa, in turn, can tell us about the properties of the ocean. How thick is it, and how salty is it?
And then we have this novel ice-penetrating radar that will try to get below the ice shell.
Last but not least, we have a gravity experiment using the communication system of the spacecraft. And from that, we can get essentially a map of the gravity field.
We can get the shape, understand what's underneath, maybe even get some information on the depth of the ocean. It's really a sophisticated payload.
The pictures that we are going to get back are going to be just fantastic.
The legacy of Europa Clipper will be just a treasure trove of knowledge about this world.
Just to find an environment that is similar to the one from which life arose on Earth would really be groundbreaking. It would be awesome.
We don't know if Earth is the only place that life got started, or if it's really common. And a really important way to get at that is to understand, is there life elsewhere in our solar system?
And we were proud to host JPL directors here at Kennedy for launch. She's with Tony now, and they both had a spectacular view of launch.
That's right, Megan. What a spectacular sight indeed. And like you mentioned, we have a very special guest with us, JPL Director Lori Leshin. Lori, congratulations first off on what a beautiful launch and now an exciting mission ahead.
What a great day. We're so excited. Thanks to SpaceX for the fabulous ride.
Absolutely. And, Lori, what would you like to say to the teams who have put in so much hard work and dedication, to this mission?
More than 4,000 people across many different organizations have worked on Europa Clipper, and we're so proud of them and so grateful for their hard work, for their families who supported them, and especially the 150 or so with us from JPL who rode out the hurricane here. Thank you.
Absolutely. And, can you tell us a little bit more about why planetary missions are important in general that we go and study?
Well, it's really about who we are. Even though it's a robot we're sending out into space, it's a very human endeavor to want to explore the unknown, and especially to want to understand where life came from, how we originated, whether there could be other life out there. It's really a fabulous quest, and we're so fortunate to be able to do that through NASA's science program.
Definitely. And, can you tell us a little bit more about the Europa Clipper vault plate and why teams decided to include one?
The vault plate is so wonderful. It builds on a great history. People know about the Voyager Golden Record, which carried messages from Earth into deep space. It's kind of following in that tradition. And to have a special poem written by Ada Limon, the U.S. Poet Laureate, we're over the moon, over Europa, about being able to carry her words with us and to carry 2.6 million names of Earthlings with us as we go explore Europa.
Absolutely. A lot of special mementos on there indeed. Now that launch has occurred, what are some of those key milestones that the teams are going to be looking out for on its way, on Europa's way to Jupiter?
Right. So just today, we'll be looking about 1 hour out is when we separate from the upper stage of the rocket. 3 or 3.5 hours out is very important because that's when our solar arrays, those giant size of a basketball field or basketball court solar arrays, deploy. We need those because we need power. And then in just 4 months' time, we'll fly by Mars for our first gravity assist. So it's going to be excitement all the way along on our way to Jupiter.
Absolutely. Lori, thank you so much for joining us again here today. Back over to you, Megan.
Thank you to Lori and Tony. Now I want to bring back Raquel, who's live at NASA JPL in California. I know the team, like here, erupted into cheers when the rocket lifted off. But now, Raquel, they're back at work and looking forward to what's next, right? That's right. There was lots of cheering over here, but now here is a live look from inside Mission Control. You can see the team is getting ready for Europa Clipper's next milestone. Now, we showed you them gearing up for this moment, and now they wait for acquisition of signal, but there's a lot happening in there that you can't see. That's why I caught up with mission manager Tracy Drain. So let's take a look at a behind the scenes breakdown. And Tracy, tell us about the space here in Mission Control.
Here in Mission Control, you'll see a lot of folks who are paying attention to the configuration of the spacecraft before launch. But our main role is to catch the baby, that's the Europa Clipper, so that we're ready to control it once it's well on its way.
And you'll be right up front here with your headset on, talking to everyone in the room. Can you tell us what is going on behind the scenes?
Sure. I, as mission manager, am making sure everything's running smoothly here and communicating status to our project manager in Florida. Next to me is the flight director, whose job is to do what their title sounds like, direct or guide the people in the room through the detailed steps of the procedure.
So if the flight director is guiding the room, who in here is talking to the spacecraft?
The primary engineer talking to the spacecraft is the ACE. They're paying attention to the link between the spacecraft and the deep space network on the ground. They actually get to hit the button that sends commands to the spacecraft when we're ready to do that. Behind them is Telecom, who's responsible for all the hardware on board, the radio, making sure that that's working so the spacecraft can communicate to the ground. And there are some other roles too, who are ensuring that the data from the spacecraft is coming to this room properly. The phase lead sits over here, and her job is to understand all the things that are supposed to happen before and during launch, so that if things start to go a little sideways, she'll be heavily involved in making sure we understand how to deal with them. Navigation are assessing and understanding the track that the spacecraft is on once it separates from the launch vehicle, so that the antenna on the ground can point to it and track it.
And then this row behind you, they're making sure Europa Clipper is healthy, correct?
That's right. While systems here is ensuring that all of the different parts of the spacecraft work together, the folks back here are paying attention to individual pieces. Avionics and flight software are paying attention to the computer and the software that's running on board. Fault protection is ensuring that if something ran on board in response to a problem, we understand what that is. Power is ensuring things like the solar array and the battery are producing enough energy for the spacecraft. Thermal is making sure that everything stays within the right temperature ranges. Propulsion is noting everything that has to do with thrusting on the spacecraft is working. Then guidance, navigation, and control and motion behavior are ensuring the spacecraft is pointed in the right direction and moving the way that it should.
And there's a special role here too, the test bed. Can you tell us a little bit more about that?
Yeah, the test bed is a set of hardware and software components in another room that we have two of them set up like a simulation of the spacecraft, so that if things go a little bit off kilter, then we can use them to troubleshoot what's going on.
And there's one more thing I'd like to ask you about. There is a tradition here at JPL that involves some snacks. Could you tell us more about this?
That's right. These are the Lucky Peanuts. And as the story goes, back in the 60s, an engineer was handing out peanuts during a launch just to ease the tension in the room. That one went really well. And so now, as our tradition is, we have Lucky Peanuts with every major event. Lucky Peanuts.
Thank you so much, Tracy.
Absolutely. It's my pleasure. Thanks for having me.
As you can see, Tracy is here now, and the entire Europa Clipper team are in high gear. This isn't the only room where the team is hard at work. Let's take a live look at an additional operation room. This is where an overflow of the team is working during and after launch. Megan, back to you.
Thank you so much for that video and tour, Raquel, because it really was cool to see all the people, again, that is making this mission possible. And we have even more people for you all to meet. Take a look.
Humans can be pretty smart, and we do discover a lot of great things, but there is still so much that we don't know.
This is like one of the most exciting times to be working in space.
I feel very fortunate and privileged to be supporting this mission. Europa Clipper is NASA's flagship mission to explore a moon of Jupiter called Europa. Here's our Europa Clipper spacecraft being built.
How do you build a spacecraft to go visit a world that exists inside of this extreme environment?
What we're looking for is what's underneath the surface.
My name is Valeria Salazar, and I help put together all the hundreds of different components that make up Europa Clipper.
My name is Andres Rivera.
My name is Jenny Kampmeyer.
My name is Sarah Elizabeth McCandless, and I am an interplanetary navigator.
I'm Deepak Srinivasan, and I work to make sure that we can communicate with the Europa Clipper spacecraft.
And making sure that Europa Clipper makes its way to Jupiter safely.
I work on Europa Clipper, helping science fiction become science reality.
We're going to Europa to determine whether we have favorable conditions for life.
Here on Earth, no matter what environment you're in, wherever there's water, we found life.
We're going to investigate all those ingredients that we think have led to life as a whole.
But to actually do that, a lot of engineering has to happen.
There's no one person that is responsible for getting the spacecraft built, for designing our science campaigns.
I'm helping enable solar system exploration, helping to enable exploration of the universe.
We're doing some really humanity-changing science.
It's a hard journey to get here. It felt like an impossible dream.
For me personally, being an immigrant, I never really imagined that I would have the opportunity to participate in something like this. Just seeing it up here and knowing that it's going to be up in space, it's pretty humbling.
Seeing it from its infancy to actual realized hardware, to get that on its journey to Europa, it's just going to be a wonderful feeling.
It's been very motivating to see that a part of me will go to Jupiter.
I'm contributing this tiny part of something that's going to help us understand better about our universe.
We're going to be exploring literally the frontiers of life.
Who knows what mission today is going to be that inspiration for the next generation.
That's such an honor to be a part of.
Jenny, I love how emotional you get every single time we see some of the members of your team. And what's incredible is, we did meet a lot, but that's still a fraction of the people who work on this mission.
Absolutely. And it's like a fraction of a fraction of a fraction. We totaled it up recently, and there are thousands of people who have worked on this project over the years. So it's amazing.
Well, and you said some people have been working towards this mission for 25 years. So that is really easy to believe.
Absolutely. And every single one of them has worked really hard for this day.
Wow. And Europa Clipper is the largest spacecraft NASA has ever developed for a planetary mission. Let's bring back NASA's Antonia Jaramillo.
Thanks to Megan. Joining me is Dr. Robert Papalardo, the Europa Clipper project scientist. Bob, what exactly are we expecting to find, with this Europa Clipper mission?
Well, the Europa Clipper carries the most sophisticated suite of instruments that we've ever sent to the outer solar system. It carries a radar that can penetrate through ice like a CAT scan to find liquid water, super high resolution imaging. We'll be able to look for warm spots, plumes at Europa, all these wonderful techniques that combine together to tell us, could Europa be the kind of place that could support life today?
That is very exciting. Can you tell us a little bit more about how scientists will indeed confirm that Europa can support life, like you said?
Sure. We want to understand whether Europa has the so-called ingredients for life. Liquid water, the right chemical elements, and then the energy that could support life. So understanding Europa as a whole can tell us whether those ingredients are there.
And Europa is an ocean world. What kind of ocean are we looking at here? Is it going to be one like Earth that has, a variety of warmer, cooler?
Too dissimilar from cold oceans at Earth, Arctic oceans, but here covered with a layer of ice. But the temperature will be similar to Arctic oceans, probably salty. We're not sure how salty. And the pressure at the bottom of Europa's ocean is probably similar to the pressure at the bottom of the deepest point in Earth's oceans. Earth has a lot more gravity, but Europa's ocean is a lot deeper.
That's very exciting. Now that Europa Clipper has launched, how does it feel for you, Bob, for the teams and everything now to see this mission on its way?
Just overwhelming. That launch was incredible. And here we are. It's the culmination of so many years of work by so many people. And now we're on our way. And 6 years from now, we'll start getting great data from Europa.
That is so exciting. I know all of us here are very much looking forward to that. Bob, thank you so much for joining us. We'll send it back over to you, Megan.
And actually, Jenny, you and I were just talking. Bob is one of those people who has been working on this for 25 years.
25 years, right? And this is really kind of I know how much this moment means to him to finally get here. And him and, obviously many of his colleagues as well. But 25 years, can you believe that?
Yeah, again, very composed for someone
Yes.
who, all of you are very, very composed. All right, so NASA made a point to keep the spacecraft as clean as possible before launching to its destination. Here's why that is so important.
I have the coolest job on Europa Clipper. I keep the spacecraft biologically clean. This means I am looking to reduce the amount of bacteria that are stuck to the spacecraft.
Akemi and her team need to keep the spacecraft as biologically clean as possible to help protect this environment as well as the other planets and moons Europa Clipper will encounter.
We're really helped by this awesome clean room here. It does a lot of the work for us. We also monitor everything that's being brought into the clean room. Everything is very tightly controlled. It's cleaned before it comes in, and we sample anything that is going to come close to the spacecraft. We're sampling in 3 different directions, and each different direction gets a different face of this wipe. We want to give ourselves the best chance to pick up any bacteria that might be on here. This is the lab where we process all of our flight support samples. So I need to take this wipe that we use to sample the spacecraft surfaces and get it into this bottle. And then I'll add some soapy water to this. And then from there, we're going to shake off all of the bacteria into that soapy water. We are using sound to finally shake all of the last little bacteria off into our soapy water.
And then we've moved to the next step, heat shock. What we're trying to do here is kill off all of the weaker types of bacteria and leave just the hardy bacteria.
Next, we're going to filter this. The liquid will filter through and the bacteria will stick on top of the filter. From there, we put that onto a plate of bacteria